Hi class, this is course 2, lesson 20, exponents and rectangular area. So we're going to cover two topics today, exponents and rectangular area. And I also believe we're going to cover square roots at the end. Okay, so exponents, rectangular area, and square roots are all going to come up today. Vocabulary: exponents can be used to represent repeated multiplication. Okay, here's an example for you. We have 4 times 4 times 4 times 4 times 4 times 4. So our exponential expression is 4 to the 6th power. How did we figure that out? Well, we have a 4. The factor 4 is used how many times? 1, 2, 3, 4, 5, 6. 6 becomes the exponent. And 4, the factor that is used, that is the base. So the base is the number that is the factor. And the exponent tells you how many times you use it as a factor. You use the number, the base. I'm going to put the base here. How many times you use the base as a factor. Okay, a couple things. If the exponent is 2, then we can say it is squared. And if the exponent is a 3, then we can say the number is cubed. After that, if it's a 4 or greater, we just say to the 4th, 5th, 6th, whatever power. Okay. This expression, or this equation, 3 squared times 3 to the 7th power, there are a couple things we can do here to help us out. And there's a property of exponents that we can use, and I'm going to illustrate what that is here. 3 squared would be 3 times 3. The base used twice. Okay, times 3 to the 7th power would be that base, 3, used 7 times. So 1, 2, 3, 4, 5, 6, 7. Did I get them? 1, 2, 3, 4, 5, 6, 7. Okay, so I have 3 times 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 3. Okay? Now, remember that exponents can be used to show repeated multiplication. So if you have the same base, we can just use the number of times that that's used as a factor. Well, notice that these bases over here are the same as these over here, right? It was 3 squared and 3 to the 7th power. So since they're all the same base, I can write this as just 3, the base. And how many times is it used as a factor up here? Well, there were 2 here and 7 here. So there are 9 total. And we're not going to figure out what 3 times 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 3, 3 to the 9th power. We're not going to evaluate that. We're just going to write it as 3 to the 9th power. But the trick here is that when you have like bases, if you have like bases, okay, so if your bases are the same, if you have like bases that are multiplied, okay, so the bases have to be the same, the like bases, and you have to multiply them. Then you add the exponents. Okay, so we had multiplication, we had like bases, so we can add the exponents. Okay, here's an example using division. 2 to the 8th power divided by 2 to the 5th power. Okay, so I'm just going to write this out as 2 used as a factor 8 times. That's 4, 5, 6, 7, 8. Then I'm going to put a fraction bar and write 2 to the 5th power beneath it. Okay, so that's 2 times 2 times 2 times 2 times 2. 5 on the bottom, 8 on the top. Now, if I have the same number in a fraction on top and on bottom and they're multiplied, those are factors. And I can divide out common factors and leave ones behind. So 2 divided by 2 would be 1, and I can do that again here. And I can do that again here and here. So we're just simplifying this fraction because we took those, whatever these numbers are, and wrote them out as a product of their factors. So we can divide those like factors out, and what's left is our answer. And again, I'm not going to simplify this. I'm just going to write down what we have. So repeated multiplication, we have a base of 2, and we have 3 factors. And so I hope you can see that what we really did was, if we have like bases, so if we have like bases, or the bases are the same, but in math we usually say they are like bases. If you have like bases and they are divided, okay, so we have to have the same base, like bases, and we have to have division, and if that is true, then all we do is subtract the exponents. So we took 2 to the 8th divided by 2 to the 5th, became 2, 8 minus 5. We took the numerator exponent, subtract the denominator exponent from it, and we get 2 to the 3rd power. Okay? So those are 2 properties of exponents that you will be expected to know. Moving on to area, units are always squared, and the formulas for area of a rectangle, we start it with A equals L times W, and the formula for area of a square is area equals side squared. Okay, remember, in a square we call the sides S, and in a rectangle we have L and W. So here is a rectangle, so we're going to use our formula for area and calculate the area. Area equals length times width. It's a rectangle, it doesn't matter which one you say is L and which one you say is W. So this is area equals, substitute in for length and width, 12 times 3. So area equals, what is 12 times 3? That is 36, and we have centimeters times centimeters, so we end up with centimeters squared. Okay, remember to square the units when it's area. The last item is square root, and the square root is the reverse of squaring. It's actually the inverse, and it undoes squaring. Okay, so we knew in that example we just did earlier that 5 squared equals 5 times 5, and that equals 25. Okay, but if I want to know what number squared gives me 25, then I use the square root of that number. The square root of 25 equals, and this is where you have to think, what number times itself? Number times itself. What number times itself gives you 25? And we already know that that's 5. Okay, that's what we're doing. Now put this down on your paper here. 3 units squared is 9 square units. So what we're really doing, or how to model this, is that if we take 5 squared or 3 squared, we would draw a square that is 3 rows and 3 columns in this example. A 5 by 5 would be, or 5 squared would be 5, and you don't have to put this on there. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that'd be 5 by 5. Okay, there would be 5 by 5, and then you count all the little boxes that you make, the little squares. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 square units in a 3 by 3 square. Okay, so what this says, this is the type of example that you'll get, or the question that you'll be asked in your book. Write a squaring fact and a square root fact illustrated above. Okay, so you look at this and you say, well, how many rows were there? There were 3. And how many columns? 3. So that's 3 squared equals how many little boxes? 9. And then you just undo that with the square root fact. The square root fact would be the square root of 9. How many little boxes did you have? Equals, what's one of the side lengths? 3. Okay, now this piece here can get confusing. So we'll talk about it in class, but make sure that you have this written down in your notes and that you've starred it or dog-eared the page, and by that I mean you folded the page in, highlight it. This will be one that you'll want to know how to do, definitely. Okay, so again, we can talk about this in class, and if you have other questions, use the note questions link on the website if you'd like me to address them specifically to you, or just in general to the class. Okay, I will see you in class.